Welcome to Everything About Robotics Explained.
Have you ever wondered how robots can pick up a fragile object without crushing it, or navigate a crowded space without bumping into obstacles? It all comes down to how they perceive physical interaction. Robots need to feel their environment to act intelligently and safely. The fundamental difference between force and tactile sensors lies in what they measure and how they measure it. A force sensor, often called a force-torque sensor, measures the overall external forces and torques applied to a robot part, like its wrist or gripper. It tells the robot how much something is pushing or pulling on it, and in what direction. A tactile sensor, on the other hand, provides a localized map of pressure distribution over a surface, similar to how human skin detects touch across many points. Think of it this way. A force sensor is like knowing the total weight of an object placed on a scale. It gives you a single, aggregated value for the force. This is often achieved using strain gauges, which are tiny electrical resistors that change resistance when deformed. When a force is applied to the sensor body, these gauges deform, and the change in resistance is converted into an electrical signal representing the applied force and torque. Tactile sensors, however, are made up of an array of individual sensing elements, often called taxels. Each taxel independently measures the normal pressure at its specific location, creating a detailed pressure image or map, much like the pixels on a digital camera capture an image of light. This distinction means they excel at different tasks. Force sensors are essential for applications requiring precise force control, such as assembly tasks where a robot needs to apply a specific amount of force to fit two parts together, or for collision detection, where knowing the total impact force is critical. They are also vital for maintaining stable grasps on heavy objects. Tactile sensors shine when detailed surface interaction is paramount. They enable a robot to identify an object's shape or texture, detect if an object is slipping from its grasp by noticing changes in pressure distribution, or even differentiate between materials based on their feel. This is crucial for delicate manipulation and human-robot interaction. Understanding these nuances unlocks advanced capabilities like robotic compliance and enhanced haptic feedback. Compliance allows a robot to passively or actively yield to external forces, adapting its motion to unexpected contact, often driven by force sensor data. Haptic feedback, often associated with tactile sensors, refers to the ability for a robot or a human operator controlling a robot to perceive and respond to touch sensations, enriching the interaction experience. Imagine a surgeon using a robotic arm feeling the texture of tissue during a remote operation. That is haptic feedback in action. By appreciating that force sensors provide a holistic view of interaction forces, while tactile sensors offer a granular, spatial understanding of pressure, engineers can strategically deploy these tools. This allows for the design of robotic systems that are not only stronger and more precise but also more perceptive, adaptive, and safer for navigating complex, unstructured environments and interacting intimately with humans and delicate objects, like.
If you love robotics, like, subscribe, and keep building with us.